Hi, welcome back to the breadboard and another TI Tuesday. In an earlier video, I had a mailbag and had received a pair of Texas Instruments CC1310 sub-gigahertz wireless modules, and I mentioned I would do a TI Tuesdays on them. So here we are. The two radios in question are one of the latest launchpads from Texas Instruments, and they work either in the 800 megahertz or 900 megahertz band, and so suitable for Europe as well as North America. Over here we use the 915 megahertz, I think it is. These boards, though, compared to the earlier modules you could get as booster packs, which, as an example, the CC110L sub-gigahertz radio, those early ones had a bit more of a limited range on them. Using my house as an example, I could get from here in the basement, which is toward the front of the house, I could get to barely the back door inside, but the minute I went outside the back door, all of the walls and everything else, it was pretty much shot by that time, and I wasn't getting a decent signal. These new 1310s are supposed to have a much better range available to them, and even have a long range mode available, which reduces the baud rate that they're working at, but which extends the range quite extensively. So we'll have a look at that as we go through this quick overview. I'm not going to do any detailed programming in this particular video because I haven't had a chance to look at how to code them yet, but I will fire them up and we'll do some transmit and receive tests and maybe have a walk and see how far up the backyard I can get before they start to quit on me. We'll do it in the normal mode first, and if they do stop before I get to the end of the garden in normal mode, we'll try the long range mode and see if that improves things. But from what I've heard, I don't think we'll even have to get to doing the long range mode because these things have a much better capability right out of the box. So let's go have a closer look at it, and I'll let you know what's inside this thing. So this is the pair of boards that I've got. They're both exactly the same, revision 1.3 CC1310 launch pads. You can see they have the XL connectors on them, which is great for a lot of the new expansion boards, and it brings out a lot more of the I/O of the boards. At the bottom here you can see in the trace this great big antenna trace for both of them, which snakes through here. There's a little ultra small connector for an external antenna if you want to put one on, up to the chip. Now this is the actual chip that does all the work. This is the CC1310 processor. This great big huge one up here is actually the standard JTAG emulator that is running the JTAG protocol from Texas Instruments. Anyway, the first thing you have to do when you want to hook this up to your PC is download the X110 drivers if you haven't done that already, and I will provide a link to where you can get those from in the post. But these are the boards anyway. I haven't changed any of the settings from the default. One of the big notable things I do see here is that they've changed the button styles to little side push ones instead of the tactile push ones, which is nice in some respects because you can just hold the board on the side and push them when you're holding the board. You've got a little couple of 5-volt outputs. These are ultra low power. So let me just go through some of the specifications of these, and then we'll give them a little run. So here I have both CC1310s plugged into my computer, and I brought up a putty session, one on COM6 and one on COM5. If I actually open up my control panel and go into Device Manager, you will see that the ports are the XDS110 class ports, and there are two for application user UART on 5 and 6, and these are the virtual COM ports that you can communicate with. So this is the default. They'll output a little menu. Now the default baud rate for these as well, they will show up at 96K, but if you set it to 115K too, that's what the demos are expecting you to be set for. So this is what I have COM6 and COM5 set to 115-200. So that's typically the maximum baud rate that your UARTs in a Windows machine will go up to. So the menus are driven by the buttons. If I just take the top one, I see I press the right hand button on the board. If I bring up a picture of the board a second to show you. So this is the board that I'm playing with. This is a picture of it, and the button I'm pressing right now is this one over here, button 2. It's allowing me to pick different menu items. This is the JTAG chip that I mentioned before, the XDS110. And button 1 is used to select, button 2 is used to scroll in the menus for what we're looking at right now with with putty. So I'm going to press the right hand button, and you'll see on this top one it's scrolling through the menus. So I'm going to leave it as a standard frequency type, the GFSK, which I think is a 50 kilobaud channel. And I'm going to change the frequency though to 915, which is in North America. Well, we can leave it for 10 packets of send, and we'll change this one to transmit. Now when I hit the left button on this one, it will start transmitting. This one down here, and the bottom one, I'm now pressing the buttons on the other module, change it to the same frequency, and I'm going to leave this one in receive mode. So I'm just going to press and start this one. So it's sitting here now waiting to receive signals from this top one. So in the top one now, I'm going to say start, and it should send 10 packets. And there we go. Now they're sitting right next to each other on the bench, so they are obviously getting a very, very strong signal. We'll change the number of packets sent to give us long enough to, so 10,000 is the most, and this one will go back to. So what I'm going to do is run this, and I will take one of them with me with my surface up to the end of the garden, and we'll see how far this will go before it gives up on us, if it gives up on us. So I just need to put a battery pack on. Yes, I'm going to need to put a battery pack on one of these so that when I disconnect it, and plug it into directly into my laptop, because I've only got one USB on my laptop, I won't lose the setting. So this one is set up for transmit, so I'll leave that one connected to the USB powered hub, and this one that's going to be the receiver. I'm going to plug in a battery booster pack that I charged up onto the bottom of this, and that way I will be able to unplug it from the USB. And let's just rearrange this. So this first one, I'm going to set it up to start transmitting. So okay, that one's beginning, and the other one we're going to unplug from the hub and plug it directly into here. So we're losing the communications with the first module, this one here. It's still sending, but this one here, we're going to just reset the putty session, set it to start receiving, and there we go, it's receiving the packets right now at about minus 30 dB. Bring it, yeah, that's very close together. It's about, goes down to about minus 10 almost when this radios are almost on top of each other. So I'm just going to move it away, and I'm just going to leave that sitting on my bench here, chugging away. That's it there. I'm going to stop the camera because there's no point, there's nothing happening on the picture. So alright, I'm way at the back of the house and am just testing the range of the module, and as you can see, I set it to transmit 10,000 packets. So I'm way back here. If I just show you, there's the house way down there, and I'm way at the end of my garden here. So next to the trees and the river and storage way over the back. Oh, the wildlife. Anyway, looks like I might be able to put a sensor way back here and still be able to get it working. This is still receiving pretty good, so I have to go all the way back to the house to be able to get it flipped into long range mode, and we'll see if that's a little more reliable or just as reliable. Okay, back in the house, I just finished the standard range check, got to the end of the garden, and it was dropping the odd little bit, but it was still working quite well. So I'm going to change the mode now to be the long range mode, and give that another go and see if it's a little more reliable, even though it's going to be slower. So I'm going to send again 10,000 packets. It'll take forever this time. Mode transmit, and I'm going to start that going because I'm going to have to disconnect it from my PC while I walk with the PC up to the end of the garden. So let's start that going. So as you can see, it's running a lot slower. It's running on the powered USB hub, so it will keep going. Now let's plug the other one back into the surface, and this bottom one here, we'll reset this, tweak the mode. So we're going to go into long range mode and receive, and we'll set start on that one. And there we go, there's our packets now being received that we're sending. Just going to put the battery pack back on. Now let's take another walk up to the back and see how well that goes. This one should be less intermittent as we do this test. Just walking through the house now. You can see the packets are still being received quite reliably as you walk through. dBs are dropping, but the packets are still coming in steadily at 1 a second. Now we're just going back outside. Walking on the deck. So now we're back out here again. Just about to head up the yard. There's some solar panels for a bit of testing we're going to do in another video. Okay, do we have steady state on the deck? We do indeed. So let's start walking up to the back. Halfway up the yard now. Passing the rhubarb. And how are we doing here? Still good at 100 dB, or negative 100 dB should I say. So we're up near the end of the yard again. So we are, now this is supposed to be able to do regional, not just in the home. So we are now still receiving pretty reliably there. I think on another video I'm going to have to start walking down the street and see how far this will actually go. So I'm way at the end of the garden again. Now that is nicely receiving everything. So here we go. That is actually receiving very nicely. So we'll walk a little bit further away and see if we still getting bitten by mosquitoes here. Still chugging away. Yes, while we're waiting here, giving it a bit of time to run a test, I'll show you a little bit of the wildlife at the end of the garden. There was actually a grey heron just took off a moment ago. Actually, I'm going to walk down to the river. So we'll test it some more. Just change that back, see how we're doing. Yeah, looks like we may have run out of steam. Oh, still receiving. See if it keeps going. Yep, still going. Just lost it there. Now you got to remember. Show you where I am. I walked down the hill. You can't even see my house now. I've got loads of dirt in the way, so I'm not surprised I'm losing it. I'm way down here. So lots of ducks and everything else, but no Wi-Fi, which they probably don't give a crap about. So let's start walking up and see if I can get it back again, see where it comes back. Yep, just at the top of the hill. So mine's 100 dB and just starting to get it back again. Yep. Now I got to remember the transmitter is in my basement laying flat, so the antenna is not exactly in the best orientation either, and it's surrounded by computer equipment. There we go. Yep. Still, that's a long ways from the house. I think if the transmitter was not in below ground level, it would be working pretty good. Let's head back to the house. So this is the main page for the LAUNCHPAD CC1310, and the reason I just brought this up is so we can have a quick look at some of the features that we have. So sub-gigahertz board, already mentioned that, sub-1 giga long-range connectivity. So we have a 32-bit ARM Cortex M3 processor on board, all in a single chip. Low power, long range wireless applications is what this is targeted for. Runs at 48 megahertz, so you've got plenty of processing power, and we have a rich peripheral set which includes ultra low power sensor controller. We'll have a look at a block diagram of the chip in a moment. Ideal for interfacing external sensors and for collecting analog and digital data autonomously while the rest of the system is in sleep mode. So that's quite interesting for low power IoT solutions. Will run TI's RTOS operating system if you want it to. Programmable with Code Composer Studio. So there's lots of getting started software examples. Obviously the boards as they come to you are already loaded with a transmit receive demo code. The CC1310 launchpads are not supported by the Energia ecosystem right now. Some of the previous TI Tuesdays where I've looked at a board and done a bit of coding, I've used Energia to do that. In this case I'm not going to be able to, which is one of the reasons why I'm not going to show you coding today. You can buy these yourself in one-off units at $29 US. If you're going to start evaluating these, I would suggest you buy at least 2 of them if you're going to, because obviously if you're transmitting you need to be able to receive as well, and I'm not yet confident that I would be able to have this communicating with my CC110Ls. They do use the same frequency band, so it is plausible that they will work together, but I've yet to try that, so I wouldn't want to confirm that. So this is the datasheet for the CC1310 ultra low power sub 1 gigahertz MCU simple link. And some of the core features that we're looking at here, obviously the ARM Cortex M3 CPU, 48 megahertz clock speed, 128K of in-system flash programmable memory, 8K of static RAM for caching, etc. to speed things up, 20K of low leakage static RAM, 2K of ultra low leakage RAM for code and data. I think this is for the power sensor controller separate to the main CPU. All digital peripheral pins can be routed to any digital I/O, so it has a matrix mapper built into the chip. Probably there is a pin mux utility to help you configure that. We have 8 16-bit, 4 32-bit timers, all with PWM capability. Nice to see a 12-bit analog to digital converter that you can use for measuring sensors and things, as opposed to the usual 10-bit, which is nice, with a decent sample rate. 8-channel analog mux in there as well. Time comparator, programmable current sources, UARTs, SPI, I2C, I2S for audio, real-time clock. Nice to see you got 128-bit security modules so that you can do some more secure communications and things like that. Capacitive sensing buttons, integrated temperature sensor. What else is in here? On-chip DC to DC converter. Anything from 1.8 to 3.8 volts, so ideal for battery mode. The active mode sensor controller, when it's running at 24 megahertz, is drawing about 0.4 milliamps. So you can shut down a significant amount of the CPU and still leave it monitoring sensors and then waking up to do some transmissions. And as it says here, one wake up every second performing a 12-bit ADC sampling is only taking about 0.85 microamps equivalent, which is pretty awesome. So it should be able to last a long time on batteries. Excellent receiver sensitivity up to minus 124 dBm in long range mode. So it's compatible with Code Composer Studio, the IIR embedded workbench, Flash Programmer, RF Studio, Sensor Control Studio, etc. So lots of things in here. Then we go on to applications. So there's the frequencies that it supports. The one that I'm going to be looking at using, because it's in North America, is 915 megahertz. Lots of different applications that this is suitable for. Active RFID, wireless sensor networks. 6 LoPan is fully supported as well. Energy harvesting applications. Nice block diagram of what's inside here. So we have the main CPU with the ARM Cortex M3. We have all the different memory options for the main CPU. And then we have this ARM Cortex M0, which is running the I/O completely independently of the main CPU. which has got the ADCs, the digital phase lock loop, DSP modems, 4K RAM, and a ROM. So this is what you would use for sensing temperature and anything else you may have hooked up independently of this, and so therefore saving a huge amount of power as you go. And the radio is connected to that too, so I'd imagine that if it receives a packet when the rest is powered down, it would be able to wake it up. So quite an extensive chip to be able to get to play with, and we'll do a lot more looking at this in future videos, but for now I just wanted to go over the basic functionality of the chip. So to give you an idea of what I've just been doing, this is my house here, and I'm in the basement, so ground level is, I don't know, somewhere like this. So I'm down in the front of the house in the basement. That's where I am right now doing this recording. And so I walk through the house, and it's a split front rear, so this is all cement. So I walk through the house, out the back, up, all the way slowly uphill to the back of the house. And this is maybe 200 plus feet. And then over the hill and down here to the river. So I lost the signal about here. And you can pretty much understand that because most of it's going to be traveling through dirt. Looking from the top, my property is very long and thin. So I was here in the basement of the house, and back here is kind of like where that dirt is that you saw, and then the river is kind of down the side here. The river is down here. So I walked up out the house onto the deck, and then all the way up to the end, down here, and then started to go down the bank. I still had my signal way up here, right? This is one profile. This little route here. And it's looking from the top. On this one is looking from the top view. This one. And this is 200-300 feet. Still got a good signal. You've got walls and God knows what in the house here to block signals. Lots of computer equipment around the transmitter. So I think, as a crude test goes, that's not a bad result from these CC1310s compared to the earlier modules. I'm quite impressed, and I think that's enough to convince me that I'm going to be using these and building a whole bunch more experiments and maybe some IoT sensor modules and scattering around, maybe put one in the back yard, solar powered, to measure temperature and things like that. Anyway, I don't want to go on any more than I need to. That's a quick look at the new Texas Instruments sub-gigahertz radio launch pads, and I think you'll agree that they've come a long way since the earlier ones, and that they do have realistically a great range on them. I think I will do another test in another video, measuring humidity and temperature, and put some sensors on it, and actually bring the transmitter up to a normal level, and then see how far away I can get. There's a lot of parks and things nearby. See if I can walk out to one of those and see if I'm still receiving a signal. Anyway, until then, I guess I'll wrap this one up. So CC1310 from Texas Instruments. I'll provide the links for you to go buy one if you want one. And I think you will like what you see. Give them a go. It's a great module, and the price is not too bad if you want to experiment. And obviously, if you're buying the chip and building one to your own board, you can see, even looking at this board right here, you've got your CC1310 right in the middle here, and you've got a few very minor number of components around it to get this thing working. So it should be fairly simple. All of this up at the top here is to do with getting the XDS110 interface up and running. So I don't think that there is anything that would be too prohibitive to make this thing work in a project of your own, even if you're designing your own boards. Anyway, that's it. I will see you next TI Tuesday. Bye.